Hello again, guys. Now, this is a problem that is a little bit more like an engineering real problem instead of just a problem to satisfy summation of forces and demonstrate that. So in this case, we have to work kind of backwards, and there's a security issue here because it says determine the maximum weight that you can hold by this chains here, assuming that these two chains, the maximum that can support in tension is 600 pounds. Now keep in mind that this statement is not correct even because if these chains are the same, this chain also here will be in question. So for the sake of solving this problem, let's uh, let's forget about this one. Let's say that this is hooked directly here, directly on that ring A. I know the solution of this problem if this chain is also, if this chain can support a maximum of 600 that's equal to this one, the three of them, the maximum weight will be this chain, period, because it's only one component supporting the weight and there's nothing else. In here we have two components supporting that weight, but the problem should state either this chain is unbreakable or this chain doesn't exist and this is directly hooked over there. And the force acting here is W. So the first thing that we have to do is creating a system of a free body diagram. Remember, I explained in my videos in the lectures uh, how to create a free body diagram, and basically you just draw a circle around the the particle that you are studying, in this case the particle A, and then you eliminate everything in the outside, and start putting forces whatever you are eliminating things. So this is going to be directly the weight. In this case, you have this component. This force is going to be AB, and this is 12 over 5. This is 13. And in this case, you know that this is 30 degrees, and this is force AC or tension AC. Now, if you look at this problem from the summation of forces, you have summation of forces in x equals 0, summation of forces in y equals 0, and that's the only thing that we have, two equations. However, it looks like we have three unknowns, 1, 2, and 3, because you don't know the weight, you don't know each one of the tensions. There are two ways of solving this problem. If you only have two chains, like this case, the easiest way to solve it will be, I'm assuming one of the chains is 600, and then I'm calculating the weight, and once I know the weight, I calculate the other tension here, and that's pretty much straightforward to do that. But if you have more than two and you have, like, say 7 or 8 or 10, I have an example like that in my study sets, then that wouldn't be the best way to go because you have to guess several times. But for this problem in particular, I'm gonna follow that approach, and it's gonna be really easy, assuming one of them is 600 and calculating the other one, and then we can calculate the weight. So let's assume, for the sake of doing this problem, if I say first summation of forces in x equals 0, let's say summation of forces in x equals 0, and let's assume that AC, the tension in AC, develops the maximum tension of 600. So if AC, I am assuming that develops the maximum tension of 600, then I can do the summation of forces in X, and you will have 5 over 13 minus 5 over 13 AB, and to the right you will have plus AC sine 30, and that's 0. So an AC, I'm going to assume that AC developed the full 600 tension. Then you can solve for AB, and AB will be 600 sine 30 times 13 divided by 5. That tension AB will be 780 pounds, which is impossible because we know that the maximum tension in the chains shouldn't be bigger than 600. That means that this result is not correct. The math is correct, but this tension AB will never be able to withstand that weight, and the whole system will collapse. That's what will happen right there. Anyway, from the beginning, from the beginning, you could know that the weakest link in reality is the tension. I shouldn't be telling you this. I should let you figure it out on your own. But if you check the angles, and if you check this angle here, for example, this angle here is going to be this angle 12 over 5 inverse tangent will be this, but this angle is this angle. So this angle here will be that minus 90, will be 22.61 degrees. When you have this type of situation, the critical link is always going to be the chain that has the smallest angle with the vertical. So you don't even have to guess. You know that the weakest link is going to be AB. And if you know that, then I'm going to make AB 600 pounds, and that's the one that is going to be developing the maximum tension right there, 600 pounds. And I can do the same thing that I did before here, but instead the same equation. But now I'm going to calculate AC in this equation. I'm going to say AB is 600 pounds, and I'm going to solve for AC. If I do that, then that will be 5 divided by 13 multiplied by, I'm assuming now this is 600, divided by sine, divided by sine 30, and then AC will be developing a maximum tension of 61.54 pounds, meaning this condition will satisfy the solution. But we are not calculating the weight. Now we can calculate the weight for this to happen. How? By doing summation of forces in Y. So if we do summation of forces in Y equals 0, then in the same free body diagram that we have over here, we can say 12 over 13 AB and AC cosine 30 minus W equals 0, and I can solve for W by passing this to the other side and using this as AB and using this as AC. So if I do that, we can calculate 12 over 13 multiplied by 600 plus 461.54 cosine 30, and that will give a total weight of 953.55 pounds. Anything above this weight, if I hang something slightly bigger than that, will make this tension in that cable to be bigger and will collapse. So the answer will be this one. I encourage you to go and check a problem that I have in the video lectures, which is a little bit more complex than this. It looks something like this, like that, pretty much like this. And then you cannot do this because it's gonna be taking forever. You have one, two, three, four, five tensions. You cannot start guessing one after the other. And there is another more comprehensive approach that I developed in that particular problem. So you have homework to do. Understand this, but go and check the other problem that I have over there. Okay? Have a good day, guys.